Hey everyone, so today we have a differential calculus problem and it's on optimization, and then we'll be looking at it after this. So it says a wire 4 meters long is cut into two pieces. One is bent into the shape of a square, the other into the shape of a circle. If the length of the wire used to make the circle is x meters, write in terms of x the length of the sides of the square in meters. Number 2, show that the sum of the areas of the circle and the square is given by f of x equals to the quantity 1 over 16 plus 1 over 4 pi multiplied by x squared minus x over 2 plus 1 square meters. So again, they want to find out how the wire should be cut, like how long must x be for the areas of the two shapes to be at a minimum. Okay, how should the wire be cut so that the sum of the areas of the circle and the square is minimum. Alright, so let's get right into it. So we have a wire 4 meters long. Okay, we'll straighten it out and then we cut it into two. So the first question was asking if it was cut into two pieces. One is x and the other is what? So this is what we'll do. We'll cut it into two. So the one piece will be 4 meters, the whole length, minus this piece x, and then this will be x meters long. This one is going to be bent into a circle, this one into a square, like this. Okay, so now they want us to find out what the length of this side is in terms of x. So we'll do this. We will say that, okay, the perimeter of a circle, of a square, is 4 multiplied by the side length of one of the sides, like, because all of them are equal. There's s, s, and s, and s here. So we add them, we get 4s for the perimeter. So the perimeter is now 4 minus x, which means we can substitute 4 minus x where there's p. And then going down, we divide both sides by 4. We get our side length, one side length, to be 4 minus x over 4. And let's put it up there. Okay, next question. Next question says that show that the sum of the areas of the circle and the square is given by that function there. Okay, so this is what we will do. We go to the other side and say, we know that the circumference of the circle's formula is 2 pi r. Then we know that this was x meters. The whole shape of the circle was made with the wire that is x meters long. So that's the circumference of the circle. We substituted the x in, then we divide both sides by 2 pi. Then we get our r as x over 2 pi. Then let's also put it up there. Then now we come to this side and say, let's calculate the area of this square. We know that the area of a square is simply as equals to s squared. Then substituting that side that we got here, we get as equals to 4 minus x over 4 all squared. And then we multiply that out, we get 16 minus 8x plus x squared all over 16. Then dividing each term in the numerator by the 16 in the denominator, we get 1 minus x over 2 plus x squared over 16. Alright, so let's go and calculate the area of the circle. Area of the circle is given by AC, area of the circle, is pi r squared. Then we now know what r is in terms of x. We substitute it in. Then simplifying this, we get area equals pi multiplied by x squared over 4 pi x squared. And we see that the pi's will cancel. We'll be left with 4 pi in the denominator. So the final answer for the area is x squared over 4 pi. Now we take these two and then we say they should add to give us this function that they're looking for. So bringing down those two, we get x squared over 4 pi plus 1 minus x over 2 plus x squared over 16. Then just with a little bit of rearrangement, putting the x squared terms together, so this one and this one together, then we can now take a common factor out here of x squared, which ends up giving us what they wanted. Okay, next question. So the next question says, how should the y so that the sum of the areas is minimum? So here we're starting to apply our calculus. We'll differentiate this. So notice that this whole thing in the bracket is a constant. So we're not gonna involve it that much. We're just going to look at this x squared term. Then we differentiate it. It becomes 2 times the whole constant multiplied by x to the exponent 1. And here the derivative of x is just 1. And this one is a constant, so the derivative is 0. Okay, then we say we know that at minimum this must be equal to 0. So let's equate it to 0. So here what happened here is we multiplied the 2 into the bracket, and then we have 1 over 8 and 1 over 2 pi. And then equating it to 0, we get this. Then let's take half to the other side. Then I want to add these two fractions. Adding them, we get 8 pi, pi plus 4 over 8 pi. So the common denominator for the two fractions is 8 pi, and then we'll have pi plus 4 when we add the two. Now we cross multiply or multiply both sides by the 8 pi over the 4 plus pi. We get that, and then the 2 goes into the 8 4 times. And then now we just simply want to write it nicely. We get x is equals to 4 pi over pi plus 4. And this on the calculator simplifies to 1.76 meters. So subscribe, leave comments in the comment sections, and I'll see you.